This is the Samsung CLP-510. It's a colour laser printer, something I've had for quite a while now, probably 5 to 10 years old. And for the past 5 years it's been sitting at home completely unused. It's always seemed a shame to kind of throw it away. It was a really nice printer on its day. It was a kind of colour duplex laser printer. It worked really well, really reliably. The tone cartridges were a bit on the pricey side, but other than that it did its job. It certainly is bulky. It's large in comparison to other units, possibly because the duplex are on there. But either way, it reached the end of its life. It's been sitting around, and rather than chuck it away, I'm going to dismantle it and see if there's anything interesting inside. The back panel seems to be the place to start, taking this apart, as it's the only one with obvious screw holes. That being access ports for expansion options. This is just had USB supports, but it did have options for possibly a parallel connection, so a network connection, and an antenna connection, so a wireless module would have fitted in there. That would have been accessible through here. No screw holes underneath, but there is a kind of connector under there, which is when it could have sat on an optional paper tray. So it could have accepted two kind of paper trays of different types, possibly different paper sizes or letter-headed options. Okay, and take a look at taking this thing apart from the top. Okay. Another piece that also needs to come out from here is the fuser. This is the fuser unit. The paper kind of runs through here, and you can actually, I'm not sure if it'll come out on camera, but you can see attached to the film there, it's writing, and that would be the last thing to be printed. Kind of makes a kind of an outline on here. This then kind of picks up the toner and deposits it on the paper, and that is part of the process. This thing has a certain lifespan to it, and does need to be replaced every now and again, so I'll put that bit to one side, but it's probably worthwhile investigating on its own. In here we've got the drum, and this apparently is another user replaceable part. Again, part of the fusing process, and as you can probably see on there, we've got writing on that, and that should just smudge off. Yes, it kind of picks up the text, kind of temporarily sticks it to this, the electrostatic charge I believe. This then presses it against the paper and runs through the heaters which fuse it onto it. And a piece like that would have probably been up to £100 to replace. Not to mention a couple of hundred, and then the toners on top of that. More hundreds, and to be honest, when you strip out all the user replaceable parts, there's not a whole lot in these things. They are almost quite empty, and so they cost a fortune to kind of completely replace the serviceable parts to them. So I've freed up some screws here. I'm hoping this panel will come away. Excellent. Top side. In here we appear to have some power electronics, some control wires here. We've got connections marked T1 and T2, supply and charger. So this might have been a high voltage, or looks like it'd be a high voltage kind of power supply for the kind of the electrostatic charge, kind of building that static charge in order to draw the kind of toner to it. There are a few interesting things on this circuit board. You can see over on this side here, there's a diode capacitor arrangement. Let me see if I can zoom in on that. It's this diode capacitor arrangement. It's a voltage doubler, and it'll be one of the methods that we're using to generate the high voltage supply. So we're using a transformer arrangement to kind of step up so far and then bumping it up a little bit further. There's also a lot of splits in the PCB here to kind of help with kind of voltage isolation, just stopping that, stopping any kind of shorting or arcing on the board. And I'm not quite sure where this T1 and T2 go to here, but hopefully as we move some more panelling we'll be able to see where these feed off to. There we go, so side piece gone. Obviously that kind of moulding there looked like that would have come away separately, but that's obviously, it's just clipped on, just part of kind of visual trim onto the design. Behind that panel there are a couple of other interesting points, but 4 solenoids here. And these are acting as kind of contact switches. So rather than using relays against the to kind of switch the power, they're using solenoids, and I have no idea why they would do that at this stage. It is old, but it's not that old, this printer, which is very unusual. And then over around here, bring in a little bit closer, there's this solenoid here, which moves this gear here from there to there, and I believe that's possibly going to be to switch the direction of the fuser. So for the duplexing mode, it pushes it out of this fuser here, which is the red rollers, which is all very hot, fuses it. It'll then, solenoid will activate, the fuser direction will change, and it will suck the paper back in and rerun it through the system, and then kind of disengage, and it will then push out again. Behind this cover is the main circuit board by the looks of it. We've got, see on the front here, it's the USB port, corresponds to that part. These 2 sections up here were for the networking. So there'll be the wireless adapter in there, Ethernet, probably status lights on there. And that corresponds to this expansion port here. So the network connectivity would have been an additional kind of plug-in option, something that could have been added at a later stage. So it would kind of clip in there and provide you access on the side. This slot here would just be kind of a memory slot, RAM slot. And on this connector here, which corresponds to this one here, and on the side of the plastic case is just represented by a kind of generic connector icon, and that is quite possibly going to be for some kind of advanced printing option, possibly kind of connecting to additional peripherals, maybe a scanning unit. And it clearly wasn't an add-on, it's a very unpopulated connector in there. So from here you've got cables running off everywhere to the other parts of the printer. Just wondering if any of this has been labelled. Waste, toner and exit. So it looks like a lot of these connectors are actually labelled in here, which is quite interesting. Else, panel from this side. Duplexing connector, and that actually appears to, that runs off to the solenoid, so it's the duplex, as I thought, so the solenoid over there does control the flow of the paper through the fuser. So it switches that. Fuser fan, so that's a fan unit. And it's all mainly acronyms that I do not know in here. Some break from the tradition down here, some flat flex cable running off to another piece underneath. One really interesting thing I did spot inside was the source of the image that you're actually printing. Now that is projected onto the drum. Now at the very bottom down here, we've got this slit here, if I close this flap, see it changes. And so when you open the toner cartridge drawer, a little plastic cover comes along and blocks this slit here. So I close that up, although that doesn't close without the toners in place. There, I can fool. Can we? Maybe not. But through there will be the main kind of optical arrangement, and that's really accurate, really sensitive unit, and that will project the kind of 4 images, the black, kind of cyan, magenta, yellow images onto the drum, and that's stored, or by the looks of it, is going to be within the base of the unit, or between there, in the base of the unit, but before the paper trays which go in. So hopefully we'll be able to take a look at that in a little bit. I'll see if I can remove some more panelling now, see where we can go from here. In the lid of the unit here is, there's not much going on here. There's a simple kind of geared paper feed arrangement. When closed, that engages with probably the same rollers that are used for the kind of main paper feed through the heaters. And that just kind of controls the paper guide wheels in here. So the paper kind of gets sucked up, passed through, I think through there, and the wheels in the lid pass it through. There's not much going in there, so I'm going to try and unscrew that lid and get it out the way. There you go. And let's remove the main brackets from the unit. So one piece to scrap. Around this side is going to be a slightly more complex arrangement. So on this side here, there's an additional paper tray. That'll be for loading in a kind of specialty items, envelopes, labels, that kind of thing. But importantly, I believe this part here is connected to the duplex in the unit. So the paper underneath can get sucked in and around, past the drum and back in again. And I think this helps with the kind of feeding back in possibly, or some kind of rotation on there. Not quite sure. All the printing action goes on through this slit here. The kind of drum fuse arrangement, or drum kind of arrangement here, kind of protrudes into this gap here. And so the paper gets pulled straight up past here, where the image is fused onto it, is then sucked into this, into the rollers here, which is still rather warm, and up and out. And so this unit on the back has definitely got to do with the kind of rotating it around, so presumably it kind of comes out and then it's flipped around somehow. Okay, we'll figure out the process for this paper running through the system here. I mean, it's got a blue smudge on here to indicate the kind of first printing side. At the moment, it kind of sucks it out the bottom, it runs it through its rollers as normal. There's nothing kind of special going on there. And as soon as it exits the top, it gets caught in the lid mechanism, which I dismissed earlier, and does a little bit more than just feed the paper out. It kind of temporarily holds it. And so if it's going to do a duplex mode, this mechanism here will then reverse. And as soon as that starts reversing, because of the kind of curve in the paper, initially when it comes out here it's quite a sharp bend and comes out a pretty sharp angle. So as soon as you try and push it back, it flicks out and it reverses through the secondary path here. It comes back through, it drops it through this mechanism here. So when this is in place, that then feeds it through here. Remember, the blue smudge is the first side we printed first. That winds down like so. So I'm going to manually guide this as it's not in place. But that then comes back around the second time, like so. Printing on this side, which is the back, and up and out through the heat fuser arrangement as normal. And that's how duplexing is performed. So what it does, once it's printed the first time, the roller's in the lid reverse direction, and the paper is automatically kind of flicked up and kind of enters this bit, it can't go back through the fuser, and this huge contraption in the door just rolls the paper kind of down and then back up on itself and out again. Now the duplex mode's out of the way, I'm going to remove this back panel here and carry on dismantling this thing. Now, interesting kind of duplex mechanism in here. There's no electronics in here except for this one kind of metal contact in here. And that's this metal contact here comes in makes contact with a pogo pin inside, and it's possible this is just to extend grounding or shielding. So there's only this one connection here that I can see. I'll have a look at this a bit later and see if there's anything inside. On the front of this unit, and contained behind this flap, is the kind of waste toner kind of unit. This is just a slightly oddly shaped unit, possibly just to make use of the space available for collecting waste toner. It's quite well designed. I think this is only the second unit I ever bought for this printer. And so it came with these kind of rubber stoppers here, which you then put in place, and so you then dispose of that normal waste. Nothing theoretically will come out. But it's this idea of this waste tone is not something I've come across before in other laser printers, so it's quite strange. Maybe the other printers are more efficient with their use of toners. Right down here is one of the entrance points for the waste toner. You can see there's a little chute in there which might not be very clear. And that corresponds to this point here. So when this locks into place, this mechanism here is what enters the waste toner. So there's a little sprung or geared clip in here. So at some point or another this kind of moves to one side and all the waste toner that's inside falls out. Presumably as it kind of runs back through, anything that's left on this sheet here is brushed off and captured in here. There might be some kind of screw kind of drive arrangement to slowly kind of move any dust or waste toner off to this end. That I think is definitely going to be worthwhile pulling that bit apart in a bit. Okay, the front panel is just connected by a small data cable. Some plugs. Just the front mechanism off. And the back here is pretty basic display. Ferrite bead around the data cable. The display appears to be a separate module in there, set behind. With any luck, that might be one of the standard Hitachi displays to be salvaged. There's a rather peculiar pattern there on the just kind of cut out with a solder mask, just the end pins. I've seen that before on another piece of equipment. I don't know if there's any reason for it other than artistic merit, but it's an oddity. I will pull that display off now, actually. So yeah, it's the display, and it is a standard Hitachi 2-line kind of 18-20 character LCD display. So it's a nice little find. Clearly they've used an off-the-shelf part there rather than rolling their own display solution, which is nice. I've got 5.1 volt label on there. Not quite sure why they'd feel the need to label that, but there you go. And for the rest on this display here, it's got the bi-colour kind of online-offline LED. A series of red LEDs which define where the error may be on a kind of a pictogram of the unit, and basic kind of menu navigation buttons. It's pretty straightforward. Okay. And behind this front panel here, got a few other electronic parts. Let's take a look at those. Behind this front panel here, got an interesting board here. Got a load of sprung connections in here. I'll zoom in on that in a minute. So that presumably runs through to the toner cartridges. So it's a kind of toner cartridge interface board, and some quite high power resistors in there, bizarrely. And also on the front, a motor down here, little worm drive. Okay, this is the second waste toner filling point. These are the two kind of filling points here for the toner module. So there's these bits here, they kind of plugs around this kind of rubbery, there we go, a bit of a mess, rubbery foam seal. And this one here was for the main kind of drop unit there. And this one here is for another waste collection. So obviously at the very bottom here, there's a little kind of capture point, and there's a worm drive here, and it's forcing waste toner up this pipe out here. And if we can get anything to come out, possibly not. And so, again, it'd be another interesting piece to look into that pipe, see how it's actually moving the waste toner from the bottom here up and into this unit there. Other than that, it's got a optical sensor in there, the mechanical fixings, more mechanical fixings, the spring for the lid. That's it for the front, I think. Back in the top is the connector here for the drum. The drum unit, this is when the drum unit plugged in, it made connection with that. This is the connector there. And that looks at to deal with kind of slight misalignment issues or mechanical shock, rather than putting some kind of rubberized dampers, this is just not done up particularly tight. It's quite an interesting idea. You've got two kind of plastic guiding pins here, which helps seat the connections in each other. So the fact that it's loose doesn't really matter. It just means the user's kind of free to slam this thing in. It's possible that it just came undone over time, but I don't suspect so. Yeah, it's pretty tight, doesn't really go up any further, and it's still loose. So it's crude, but quite a novel solution to that problem. Behind this unit we've got the power supply, and it looks like it's divided, it's partially into two sections. It's got the main power feed coming in here. Let's connect that, that'll be from the IC connector on the back. Kind of filters, kind of into a fuse here, various kind of filters, kind of clean up the feed. Obviously there's going to be a lot of motors, heat elements switching in and out solenoids, so there'll be a lot of noise generated in the system, and that's to protect it from kind of emitting radiation. and second fuse over here. So the label on this board here is Sun Korea Electronics. And one of the other control boards up here was Dongyang Instruments. So possible trading partners, trading names of Samsung, but so far no obvious Samsung branding in here. So we've got kind of power coming through here. There's various filter arrangements. Something's going on there, I'm not quite sure as of yet. We've got connections running up here. This is possibly for the heater. So it's going to need a lot of power of that. Running through to here, we've got a bridge rectifier, a large smoothing capacitor, and kind of switch mode power supply arrangement here. And then an Optical kind of bridging between the two halves. Presumably within here we've got a secondary power supply of some kind. There's another slightly higher power output there. I'll remove this from the metal mounting and see exactly what's going on. Taking the board out, and from behind you can get a much better idea of what's going on. The power kind of enters in the top here, passes through kind of fuse, filtering capacitors, got a varistor by the looks of it, just to clamp the supply. Kind of common mode inductors in the filtering arrangement here, running all the way down to here. And this is the output from the heater. I believe this is just going to be a switch, possibly a MOSFET, something like that. You can see that is controlled from here. And so the whole board here, you've got quite a large gap all the way around the high voltage electronics. And this, we've got a couple of control lines here, which snake their way around the edge, kind of keeping to the low voltage side. And that'll be to switch the high voltage output. And of course here you've got the bridge for the opto isolator, you've got the high voltage and low voltage side of the switch mode transformer. And these kind of control wires look like they go straight through to the connector on there. On this side of the unit we've got two kind of stepper motors in here, and these are kind of PCB mount ones by the looks of it. They look identical, these two. That's kind of a kind of stepper motor module, which has got some kind of some control electronics on the reverse of this board, and kind of data signal coming in. There's quite a few control lines in there, so it's possibly some kind of feedback mechanism as well. So here we go, this is the stepper motor board. Nidec manufactured part. And they've rather wonderfully labelled the connector on the board here. So you've got two 24 volt feeds, two grounds, three kind of power ground, signal ground, 5 volt, start and ready, clock, counterclockwise, clockwise. So that could be a wonderful part to actually try and get running. So it should just be a case of giving it the right power feeds, clock signal, which presumably is the speed at which it's rotating, clockwise, counterclockwise, you kind of high-low to tell it which direction to turn, and start and ready could be presumably might be a pulse on the start signal to get it to go, and while ready might be like a high signal to kind of maintain it in that state. That's quite a beefy unit by the feel of it. It's got a interesting gear drive. Name escapes me of that type. But by the looks of it, that could be replaceable if we can remove this metal plate from it. And it's its own control electronics managing that. And we appear to have at least 2 of these boards in this unit. On the other side, we've got the second kind of board, which controls the gearing up here for the heated rollers. And then if you change direction, okay, so yeah, obviously with our clockwise counterclockwise signal, there's no need to use a kind of this solenoid here to change the direction of the motor. And so the rollers always go in the same speed. And this signal here, or this solenoid, will just control presumably just control the direction of the top feeder unit, which did do the duplexing. So I'm going to remove this and also this fan and kind of funnel arrangement now. That was the first cable tie so far in this. It's all bundled together with clips and other neater arrangements. There we go, our second stepper motor. I believe let's do the same. Oh, different markings actually. Possibly different power ratings, both 24 volts, same kind of control signal coming in, same manufacturer, slightly different model number. We've got 38A and a 21A, possibly a higher power, might be slightly higher power magnets in there. Got the same kind of screw drive mechanism on the back. The other side of this plate here looks a little interesting. It appears to have some kind of mechanism for each of the toner cartridges. It's actually the motors for each of the toner cartridges. They then cross over to the boards we looked at initially with the solenoids on. And so I'm still not sure what they're being used for, what they're switching. Almost like some kind of isolated mechanism for each of the toners. So removed a few too many screws from here. So these plates should be joined together. It appears to just have, the looks of it, standard motors in here. Although, oh no, there's a single feed here. So this is from the solenoid, sorry, from this motor here. That would have gone in and rotated this mechanism. This mechanism here then rotates all of the toners, and then these will be switches to kind of switch the gearing mechanism in and out. I should have read the label on these first. You can see it is an electric clutch. 24 volts, 160 milliamps. So like a lot of things, it will trigger at a lower voltage. So, feed it into this battery pack here. There's a slight click. See this end unit here, which I'm powering up, is rotating. Disconnect the battery, and it stops rotating. No idea what use something like that would be, but it's a fascinating piece, and I've got 4 of them. Back to this board. Let's get this out. Let's see what this thing is for. So there, it's freed up. This black wire on the top goes through to the first board up here. It's a connection marked supply. Just like that, all through. And this then connects to the main board using the flat flex. So these are the clutch connections, pretty much marked as so. And a clutch 1 to 4, solenoid 1 to 4. And so let's see what these switch. So that's how the switch is working here. So this is same thing a relay would do. There really doesn't seem to be much use for this. So one side here is for the supply, it comes in. These other ones then connect to these 4 terminals. This is the these are the sprung terminals in here. And those sprung terminals connect through to the toner cartridges. So on the side of the toner cartridge, this terminal here. On the other side there's 3 others. So it's possible as a real kind of enhanced safety measure here. It's kind of completely disables the toner mechanism. So using this board here, it isolates the supply going to the toner cartridges. Obviously you could reach in and feel these kind of pins in here. There's nothing stopping you doing this, and if that, depending on the voltage on that supply, that is high, that could be pretty dangerous. And so these solenoids here would then isolate that. I don't know what their connection would be to the motors. Again, the clutch mechanisms do have a role to play in isolating the toners, but they seems a little unusual. Maybe they aren't connected to these and it's just using the same board in here. Either way, I've got myself 4 what voltage are they? 24 volt solenoids. So a nice pull from this, I wasn't expecting that. So in here we've got another clutch mechanism. Well, not necessarily a clutch actually, this just stops rotation. It's kind of a solenoid that pulls in a plate that stops it rotating so much. That is a clutch though, it even says so. Another 24 volt, same mechanism by the looks of it. Okay, power it up. And whilst that's not fully stopped it, it doesn't spin freely anymore. It's possibly played a part with whatever else it was connected to. And I guess this isn't 12 volts, 24 volts I'm running it from, so that might be why it's not hugely effective. See there, it doesn't really move. And disconnect, kind of spins freely. These kind of gears are probably worth keeping, but it depends what you're doing. I'm not sure if I'd really find a use for them. Although they do, it is the kind of same angled tooth, so it would work well with the stepper motors. So it could just be useful for interfacing with that, converting the stepper motor motion. Along with the screws, little springs like that are probably going to come in handy, be worth keeping hold of. And that bracket there was just for holding the cables. Someone designed this to kind of fit and accommodate with the rest of the kind of moulding, just to hold this kind of bundle of wires as it ran through. Whereas in other places, another point was one of these kind of little metal stick-on clips. Obviously the kind of adhesive goes after a couple of years. These are quite nice for short-term use for some applications, or if you could screw them on, then you just wrap the metal around to accommodate whatever size cable bundle you need. Versus that, it's just an odd combination. It's the waste toner sheet. Let's kind of drop down there. It's already dripping stuff, so that's going to in the bin. This is a dual purpose board, this one. It had a connector running off for the motor for the waste toner, and it was interfaced with the toner cartridges using the same sprung clip mechanism. And some of these other subboards, the connectors here, these are soldered directly to the board. This connector doesn't unplug. Obviously it connects to the main board using a cable, so if this failed it would be replaced as a single unit complete with kind of cable. Obviously it means the engineer, if they bother to repair these at all, would need to feed this through the entire mechanism. As I thought, this appears to be some kind of worm drive assembly. So I rotate the motor on the other end. You can see that then rotates there. It's an interesting mechanism, but it's going to be full of toner, so it's apart from the motor, it may go straight in the bin. Little Optical isolator board. Detected the paper exiting the printer, that one. An even bigger Optical isolator in there, which is detecting the presence of the waste toner cartridge. The best thing to do now is to remove this fuser unit, I think. So there we go, it's the fuser as a whole unit. So the main power seems to interface through these kind of main contacts on the sides. You've got a temperature sensitive switch in there to switch it off, possibly as part of normal operation, so it would turn on and this would maintain its temperature. Little sensor in there, it's possibly a temperature sensor kind of brushing against the red roller, the drum, so that could be the primary source. So yeah, these are the two main kind of push terminals for the heater. So kind of there's two heaters in each of the rollers. As the power kind of comes in here, kind of loops into both terminals there and round through on the other side. And so they could be useful as they are, but they're a very kind of specialised unit. This is kind of a rubber, kind of the red material in there, slightly rubberized. You can see the heating mechanism is basically a big halogen light bulb in there. And so whilst it's interesting, I don't think it's going to be particularly useful. A temperature sensitive switch can certainly come out and possibly investigate that sensor as well. I think that's the bulk of the interesting part. It's now time to really strip this down and get to the kind of the optical arrangement in the base. So this is the optical sensor which detected the presence of the waste toner cartridge unit, and it's rather than a small integrated package like this one is. It's a single piece component that detects if something kind of breaks that beam in there. This is a homemade one. Got the two kind of emitter and receiver LEDs in the back there. So they shine through slits and just take the presence of this larger unit. And this is an interesting arrangement. And a big kind of array of LEDs in there. Now, this could be an arrangement, could be there to kind of clean the drum kind of electrostatically, so to kind of somehow wipe out or clean off any additional charge. There's another one of these units lower down in the printer. Something I'm not really that clear on this. Also in the unit here is a little temperature sensor. It's on a dedicated board. Looks like some kind of just ambient temperature sense, just to make sure there's nothing really going wrong. This is at the higher end towards the exits of the paper. So there's a single array of LEDs. Connected up in two chunks, with current limiting resistor for each one. It will could be useful on its own, but it might be worthwhile powering it up just to see if it is actually a red light or something else. After removing a lot of screws, this thing's really losing its structural integrity. And I've also finally gotten access to the bottom panel. Got good enough access anyway. Okay, it's gone. And so here, this is the mechanism which closed the shutter when the drawer opened. So I'm just going to remove this drawer mechanism. Take a look at this, the optical assembly in here. You can also see the other arrangement here, the other kind of red LED assembly there. Unscrew this module from the chassis. There we go, the optical assembly. This was very securely bolted to the bottom of the unit. Protected around. And also integrated with the kind of mechanism to close the lid was this brush shutter here. So it might have been its primary purpose to kind of keep the optical window clean and clear of dirt and toner. So this is the assembly here. It's bolted to this kind of outer surround. And here's one PCB visible there, connector. Move that one. And the other connector on the other side. Presumably that was probably for a stepper motor in there. Let's move the cover and take a look. Big metal cover with possibly glass in there. And this is all it is inside. Got a laser diode over here. and that shined onto this mirror here. Basically, the mirror kind of has 6 sections to it. So obviously it hits there, then kind of bounces out, and the arrangement here allows a single pass here to sweep the beam across here. Presumably the shape of this possibly designed to kind of ensure a smooth optical path, or kind of continual optical path, so there's no, because obviously as it hits here at different points the length will differ, so that might be to make that more uniform, or to kind of possibly even spread it further. That then shines through the slit here onto the mirror and straight up and out. There's also another optical arrangement here. So the looks of it, that might be to catch the signal at the end of the path. So as the beam sweeps across here, it'll reach a point here where it just about clips this other mirror in there. The beam then gets sent across through an optical filter and into the sensor there. So that might be designed to tell it that sweep's finished, or that's its extreme, possibly some kind of calibration routine. It's a pretty simple board in there. Yeah, so obviously that's a stepper motor under there. Mirrors on the side. So yeah, so that's the heart of a laser printer, a laser copier. It just projects the image onto the drum, kind of line by line, colour by colour, listing lots of single sweeps. There's probably a few salvageable parts in here, the laser diode and the stepper motor, but probably going to keep this together as a whole, at least for now. It's quite an interesting unit. So that's the bulk of everything cleared out of this frame. There's very little left. It's a motor on there to pull out. Still kind of an optical sensor in there. Basically gear arrangements, maybe the pulley. Another solenoid in there. And a couple of switches. Oh, I'm sorry, a switch up there, and you've got a main switch and IEC connector, and another solenoid in there. So I'm going to strip out these final pieces now, and that'll be the end of that marathon dismantling process. So it took a little while to strip all those bits down, but yeah, at the end of it I've got a good selection of parts and an awful lot of plastic to dispose of. So that's all going to be bagged up and moved off to the tip. As far as the haul goes, I've got half a dozen more solenoids, an interesting geared mechanism I haven't looked at yet, 2 really nice stepper motors and controller boards, the Hitachi 2-line display on there, and then there's the kind of circuit boards, power supply boards. The filtering should be worthwhile pulling off of that, and maybe the odd other bits in there. The huge selection of screws, cogs probably of no use. A lot of kind of opto isolated opto kind of brake kind of detectors, and they need to be stripped out. The optical arrangements, a single fan, surprised there wasn't going to be more in there, and obviously a large array of clutches in that mechanism, the odd connector. And so yeah, it's a pretty decent selection of parts actually, a few more than I was expecting, and it's quite interesting to see how some of the parts kind of went together, certainly how the duplex feeder kind of worked to feed things through. And it didn't make as much mess as I thought. This bit kept having to, needs to be hoovered. It's the waste toner mechanism. But in all, I'm quite pleased. It was a decent printer when it lasted, while it was running, but it served its time, and I think this is a fitting end for it.